So when we start thinking about images, remember that the plane mirror always gives you a same size image. So that's an option. But if you curve the mirror at all, you're going to skew the lines a bit, and that's going to cause the image to be either increased or decreased in size. So we call that the magnification. This is somewhat like acceleration, where we don't use two different words for acceleration or deceleration. We're going to use the same word, magnification. That could mean that it gets smaller. So what we're looking for with magnification is it's a ratio of how high the image is compared to how high the object was initially. So notice our new terminology, HI, which is the height of the image. Again, we're going to draw a principal axis, and then we're going to have our mirror here. And so when we draw the object, the height of it is measured from the principal axis up to the top. The height of the image then, wherever the image ends up, we will measure that height from the principal axis. So those are measured perpendicular to the principal axis. You will sometimes find images that are underneath the principal axis. So sometimes your image is on the same side, and sometimes it's on the opposite side of the principal axis. This is a positive image height. This is a negative image height. So keep that in mind. Positive if it's upright, negative if it's inverted. So inverted images get a negative, and so magnification is negative in that case. The negative doesn't mean smaller, it means inverted. So sometimes we have reduced images, sometimes we have inverted images. We'll be able to tell that by looking at the magnification. Another property of an image, and one that actually your eye is unable to detect, but that we'll be discussing, is whether an image is real or virtual. As the rays begin to converge to create an image, sometimes those rays actually cross one another, and sometimes those rays don't cross one another. And so if we have an image formed by the rays actually coming to a point and forming an image, then we're going to call that a real image. If they don't, then we're going to call that a virtual image. So surprisingly, because we're so familiar with plane mirrors, we don't maybe think about it, but we did this plane mirror earlier. We had the image here, and the object here, and we ended up with our image back over here. So this is the image, if you remember from our previous drawing. And notice that it's on the opposite side of the mirror. That means the light doesn't actually get over here. There is no light that gets behind the mirror, but your eye creates that image behind the mirror. And so this is a virtual image. It is not a real image. When the object and the image are on the same side of the mirror, then we would have a real image. Again, not the case here. When they're on opposite sides, we have a virtual image. So your book gives you this picture of drawing a ray diagram, and it has three rays. It has the parallel ray, the focal ray, and the central ray. These are just three of very many rays that you could draw, but because these particular points, the focus and the center, have some specific properties, we can use them to draw quickly. So the focal ray, which is drawn in green here, is from the object. So you start at the tip of the object here, and it goes through the focal point, and as we saw before, light that goes through the focal point gets reflected parallel to the principal axis. Really important that you have a straight edge as you're drawing these, so that you can go the 2 points, top of the object, focal point, all the way to the mirror, and then draw your reflected ray parallel to the principal axis. The second ray they have drawn here is the parallel ray, so it's in blue. and it's from the tip of the object parallel to the principal axis. Here's the principal axis right along the bottom here, and then the parallel ray is going to go parallel to the principal axis and through the focal point. So this is the opposite of the focal ray. The focal ray goes through the focal point and then parallel. The parallel ray goes parallel and then through the focal point. With just these two, we can find the image because they both will converge. But just to make sure, we want to go ahead and do a check. And so the central ray is a check ray here in this option, in this picture. So it's drawn in red. And if light goes through the center, that means it's going along the radius of curvature of the mirror. And so if I were to draw a normal, it would be perpendicular, and so the angle of incidence is 0. That means the reflected angle is also 0. So it reflects right back on itself. So I start at the tip, I go through the center of curvature, and it reflects right back on itself. So let's look at our first case, one where the object is located at a greater distance than the radius of curvature. I will note earlier I mentioned to you that DO is the object distance, and that is the way that you will find it on sapling, but your book uses SO. So let me make that clear. DO and SO are the same variable here. So in this case, I've got radius of curvature. Remember, the radius of curvature is the distance between the point where the principal axis touches the mirror and the center of curvature. So those are, this object is out very far from there. So I'm going to mark my focal point. I know where my focal point is because the focal length is half the radius of curvature. So the focal point is going to be halfway between the center of curvature and the point where the principal axis touches the mirror. And so we've got the 3 rays. We've got this parallel ray, which we did in red earlier. Again, super important you use a straight edge. I'm not able to do that on my tablet, so I'm going to do my best here to make that parallel to the principal axis. If it's parallel to the principal axis, then it gets reflected through the focal point. Make sure to draw the arrows because you're going to put a lot of lines on here, and it's important that you know which one is the incoming and which one are the reflected. The reflected rays are going to tell you where the image is. Okay. Then I'm going to go to the focal ray, and the focal ray goes through the focal point and then gets reflected parallel to the principal axis. So there's the incoming and outgoing. And then my final ray here is the central ray, and it's the one that's going to go through the center. I can already see where the image is going to be right here, but I'm going to double check with my center of curvature ray, and it is both incoming and reflected. And so now I can put on the image on the picture my image. So can label everything. This is my image distance. Again, your book is going to use SI, and sapling will usually use DI. This is my object distance. And so the image distance, couple of things to notice. I've got a smaller image, I've got an inverted image, and the rays actually cross here. So this is a smaller inverted real image. Those are the 3 things that we want to be able to say about every image. Your book does this, and they show you the picture of this person. So this is the person's head. So that's your object. And when you look at the image, here's the image. It's inverted. It is smaller. If you look, here's the size of the person's head. And so the person's head is smaller. It's inverted, and we can't really tell. We just have to know what's happening with the light to know that that's a real image. So here is the image that is from your book and gives you the nice straight lines to look at.